Okay, last but not least, we are going to solve quadratic linear systems of inequalities. So, really the key to success here is being able to appropriately graph a line and a quadratic, and being able to identify the two of those. When you are graphing these, you need to make sure that both the line and the quadratic are set equal to y, so that you can graph your line in slope-intercept form, which is y equals mx plus b. And the quadratic is set to y so that you can put that into your calculator to come up with your table if you need to. You're going to graph the linear equation, taking note of whether the line should be solid or dashed. You're going to use a test point to shade in the appropriate direction. You're then going to go back and graph your quadratic. You should come up with a parabola. Again, decide if it's solid or dashed. You're going to use a test point to shade again. You're going to determine where the two shaded regions intersect, and you're going to mark this with an S. That is to indicate the solution. Please remember that there is not just one solution for a system of equations, but many. Okay, they're all of the points, okay, that make up the ordered pairs within the double shaded region area. There are actually infinitely many solutions to a system of equations. So let's take a look at this first one. So we have y plus x squared is less than 4. We have 2x plus y is less than or equal to 4. So let's take a look at the top one here. We have y plus x squared is less than 4. This is a quadratic. The reason I know this is a quadratic is because it has an x squared, but y is not squared. If y was squared, then we would be looking at a circle or another conic depending on the way it looked. So what we need to do is we need to set this to y. So I'm going to subtract x squared from both sides, which is going to turn this into y is less than negative x squared plus 4. At this point, you may be able to graph this without assistance of a calculator. If you do need the assistance of a calculator, you can go ahead and grab your calculator. I'm going to use the Inspire here. I'm going to open a new document. And I'm going to put graph in here. I'm going to put negative x squared plus 4 in. If I press enter, this is what the graph is going to look like. However, we know that if we have an inequality with no bar underneath, that's indicating that this is going to be a dashed parabola. To come up with our table of values on a TI-84, we'd simply go to second graph. In an Inspire, we're going to press Control T, and we'll get that nice table of values here. So I want to try to find the axis of symmetry. I think I found it. I can see that seems to be that my y values are symmetric around the y value of 4. So my axis of symmetry is right here at 0, 4. I can't graph negative 4, 12, so I'm going to start at negative 3, negative 5. I'm going to create a table of values here off to the side. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Remember my turning point was at 0, 4. Let's go back and see what our other values were. So we have negative 3, 5, negative 2, 0, negative 1, 3. So this was a negative 5 here, negative 2, 0, negative 1, 3, and then it's going to bounce back around. Oops, that's not a negative 4, that's a negative 5. So we're going to go ahead, we're going to plot these points on our table. So over -3, down 5, over -2, down 0, over -1, up 3, over 0, up 4, over 1, up 3, over 2, up 0, over 3, down 5. And then I'm going to do my best to make a dashed parabola. It's not pretty, but it will do. I'm going to have arrows at the end of this. I'm going to label this with its original equation. Y plus x squared is less than 4. I'm going to choose a test point of the origin because the origin is not on my parabola. And I'm going to test this back in my original equation. So I would have 0 plus 0 squared is less than 4. Is 0 less than 4? Yes, it is. And therefore, I'm going to shade towards the origin, which is going to allow me to shade inside of the parabola. I'm not done yet though. Now I need to go back. I need to look at 2x plus y is less than or equal to 4, and I need to graph this. In order to graph this, I'm going to have to put it in slope-intercept form. I'm going to have to move this 2x over. So y is less than or equal to -2x plus 4. So I'm going to start at positive 4. I have a slope of -2, so it's down 2 over 1. Down 2 over 1, down 2 over 1, and so on. I like to plot lots of points so I can be accurate. Looking, I have a bar underneath, so this is a less than or equal to, which indicates that my line is actually going to be solid. Do my best to draw a nice straight line. I'm going to label that line with its original equation. So it's 2x plus y is less than or equal to 4. And now I need to use a test point. I could use the origin again, since the origin does not intersect or is not on the line. I'm going to substitute back into my original equation for my test point. So that's 2 times 0 plus y is less than or equal to 4. Oops, I'm sorry, that y should be a 0. So that's going to be 0. Is 0 less than or equal to 4? Yes, it is. It checks. It's a true statement. So that indicates that I shade again in the direction of the origin. So anywhere where my two shaded regions intersect, it's going to be where my solution is. And I'm going to mark that with an S to indicate that solution. Please go on and try number 2. When you're finished, please go on and complete the matrix review. Please be aware that in that matrix review, you are going to be adding, subtracting, using scalar multiples, and multiplying matrices. So you're going to have to switch gears there. Good luck!